Another area that has been a recurring story is PDE modeling that we continue to build out. We built a solid finite element solver that handles a really broad range of PDEs. And for the last few years, we've been building out a higher level language for representing things that the particular PDEs that come up in different domains of mostly engineering, but also sort of physics domains. So in this release, we've got new high-level constructs for time dependency in electric circuit modeling, and in solid mechanics, we had stress measure before, but we only had one stress measure, and there's various different concepts of stress. So there's a whole bunch of new stress measures that we can compute for solid mechanics problems. And I brought one example with me, which is in fluid dynamics, axis symmetric systems, because axis symmetric is a whole class of problems that we've been building out in other domains. And that is where you have a problem that is a problem in 3D, but fluid dynamics is one where axis symmetry comes up quite a lot because fluid dynamics often happens in pipes. So here we've got a pipe that goes through a constriction and then into a fatter pipe. But there's an axis that it's got symmetry along. It's round. So we can, in fact, consider this as being a two-dimensional problem in terms of the right-hand half of a slice through the pipe. So here's the thin part, the constriction, and the fat part, and solve that in a generalized two-dimensional way. And that allows us to solve it much faster and more accurately, and then visualize that or compute with that generalized back into the 3D. So that vortex that we computed in the 2D slice, that generalizes round into 3D. So for problems that can be considered in this axisymmetric way, we now have axisymmetric methods for quite a few of these different physical domains, fluid mechanics being the new one. But in the end, these are all pretty obvious things that if you're doing sort of multi-physics and engineering type things in the real world, then it's all about having a higher level way to describe them and then simulate the PDEs that underlie the behaviors.